Everyone, and welcome back to the Information Bottleneck. And today we are hosting Pierre-Carl Langlais. He is the co-founder and CEO of Pleias. That this is a French-German AI lab that focused on data research. So, hi Pierre, thanks
Hi,
for joining us.
nice to meet you all.
And today we're going to talk about many topics, but I think we can start with synthetic data or like data generation and why it's so important these days and what you think are the maybe the major bottlenecks in this area.
Totally. I think right now, I think it's important for two different aspects we are kind of focused on different sides. The first one is about learnability and efficiency to learn something within the model itself, and especially memorization. So that's the focus we had when we released this thing called SYNTH, which is a synthetic pre-training data set, which is kind of unusual because most synthetic data is more done for post-training usually. But we did this idea of, okay, what is the minimal amount of information a model should memorize, basically? And since I was in Wikipedia for a long time, I was a Wikipedia admin, I knew there was this thing called Wikipedia Vital Articles, which is basically like a curation from the community of everything that you should know about, which is kind of a good shortcut of, okay, what is actually everything a model should know? Because if we are realistic, actually everything we read for our life is kind of tiny. We read like maybe a few hundred books, this type of thing, but we still know a lot and we can still converse. And the idea was whether, okay, how can model memorize all these things? So there was this first idea of how we can use synthetic data for what is called synthetic rephrasing, but more like a way to amplify information, to create variation, to avoid collapse you'll get if you just repeat the same information inside of the models. And now we are exploring a variety of other techniques to enhance learnability, and I can talk about that later. The other topic, which is really hugely important because we are a French-German labs, as you underscored. So we are in Europe, and we are mostly working with regulated sectors, and it means working mostly with sensitive data. So just last week, we released a model with the subway of Paris. We work mostly also closely with the telecom sector, with banks, and all these kinds of things. And there are two issues here. The first one is that the data is not really in pre-training data right now. It's not really in the big crawls. So the model are not that great actually for many tasks they want to do, even the frontier ones. And the other issue is that they cannot really use their data for training because it's sensitive, and even internally it's complicated for them to share actually. Even from one service to another it's complicated. So here, and we can talk about that more in details. And I think it's really about how we can simulate data we don't have, basically, and simulate it in all kinds of ways, in terms of formatting, in terms of content, in terms of process, in terms of infrastructure, all these kinds of things, which is kind of very connected to what Frontier Labs are doing right now with environment and all these things. But with these more specific targets that we have right now as a company, actually, not just a labs, but which is really about how we can basically create good models for customers which are not having them right now.
But the idea is like to create a model that we can pre-train on this data, and that this model will be like comparable to model that are trained on like large amount of data. What are so why to do it? Like one is like say like we want like I know smaller like amount of data, and the second one is that because like now we know exactly the license and like the thing that like actually like the model like the data like the properties of the data, right?
Totally. I think that's one of maybe there's three reasons, and in the end, but I think the first one is exactly that. You want to train a model that are going to be much smaller because it can run on premise. That's what we did actually with the French subway. We trained a 600 million parameters model for the monitoring systems. They used to use a very large model for this, but then they had to send the data through API. And it was kind of sensitive because it's a lot of complaints, for instance, by users. It's a lot of tweets, for instance, sent by travelers when there is someone sick on the subway, this type of thing. And it's not a trivial task either because there is a lot of understanding, interpretability you have to put to and really understand, okay, it's not a hoax, it's really something happening, this type of thing. So you have to take all these context clues. But yeah, we create simulations of the kind of data that we're receiving at scale. And we published this paper in SCL. It's been accepted as SCL funding. And we managed basically this way to kind of reduce the size of the model. Second one is really about auditability, which is again really important for this sector. Actually, it's kind of mandated also by the AI Act in Europe, but even interprofessional agreements. I think even in the US, you can have this kind of requirement that you want to audit the system. You want to know exactly why it does behave in such a way without having a black box. So synthetic data is really nice in a way because I think, and we can talk later about this issue of ethical data because we worked a lot on this before, but it's kind of the way to make sure that we can get data that can be releasable and still very competitive because you can use basically all the latest advancement and say it's releasable because by default, I would argue that all synthetic data is public domain because there are no authors, there are no copyright. So this is the approach retained by Frontier Labs. Right now, we see a lot of talks about model IPs and control over synthetic outputs, but still, it definitely allows much more flexibility into sharing the data, also because you can remove anything that can be sensitive because you can simulate it and so on. And I think the third one is really about even unlocking new capabilities inside of the model itself, because once you work with environments that can be very different from the ones models are being trained, and that's the kind of thing working, especially in telecom right now. We have a partnership with GSMA, which is one of the conglomerate for telecom industry. We're going to release a corpus together actually this week. And it's really about, we want to get good models for dealing with log systems in telecom systems, this type of thing. And right now it's really the kind of thing which are in a way at the frontier because it's not really the kind of thing when even good best models are not really being trained on that right now.
So what do you consider to be like ethical in the context of data sets? Because I think that's something that you've worked in for a while, is trying to create data sets that are not, mired in claims of copyright infringement and myriad other notions of problems. So how do you define that?
I think it's a very good question because when we released the paper on Common Corpus, we did not say just the largest, like, freely reusable, copyright-free, whatever you want to do dataset, but we put intently as the largest ethical dataset for training, which was kind of intentional on our part. So I think ethical, usually the most basic concept is more about data that you can release, that we can audit, that there has been some kind of consent for shareability. And so usually, but there are a variety of approaches. Several actors try to do that, and we try to do it with Common Corpus. What we've made concretely is first and foremost navigation of everything while you have a guarantee that you can reproduce it, including for commercial use. So basically, it means everything under free license, everything under public domain because copyright have expired, everything that never have any kind of rights because, for instance, it's public domain of information, everything that is open source, for instance, for everything that is under free software. And importantly, it also means we can have attributions, which is another criteria on top of it. It was especially important for anything that is free license. You want basically to maintain and to quote. So in Common Corpus, we have the mention of the authors, and we want that we can know it, but the case is that we have this kind of attribution being maintained. Obviously, not once the model is trained, which is also a part of contention in that space, but still we wanted to maintain it at the scale of the data set. We want everything that is transported to maintain attribution. But then there is the third one. Actually, we are kind of very conscious about that, which is more about other things, like, for instance, multilinguality, the question bias, structural bias, which is something actually we worked much more on right now on Common Corpus. And we're also kind of really expecting also synthetic data to unlock that, because originally Common Corpus were really, really Western biased. It was mostly like Europe and US, mostly, because that was kind of easy to get this sort of information. But in the latest release we've made in February, we added a lot of content. We have a big Chinese data set. We added a lot of content also from India, from Japan, from other countries. And with GSMA, actually, we have now a collaborations where we trained a very small language model for language detections, which is the kind of core bricks you need to be able to identify even low-resource languages, because there's kind of negative feedback loops where frequently we don't even have the tools to identify it. So I would say ethical is also this part of things, which is really about how actually data is kind of representing the world you put inside of the model. So it's not just about, just the information in a vague sense, but it's really much even like worldview and everything you have to get accessible. And kind of the vision that we have right now is also about, correcting for this type of bias, creating also the tooling that is going to help, for instance, to digitize content in many African countries. We have deployment projects in Senegal right now, and we see definitely the interest to have also models that are being much more culturally attuned. So I think that's also that dimension basically that we want to push for, and also the reasons why we also push for this concept of ethics in a kind of broad sense. But I think it's also a bit kind of loaded because ethics is not the same as Anthropic would claim to have a concept of ethics, which is definitely not ours, which is much more anchored in openness and transparency. But we still wanted to push towards this wider conversation.
So how can actually like you build in practice? Like, okay, we have the idea. We want to build a data set for pre-training. We understand why it's good. What you actually do in order to build it?
So I think the funny part is that actually I started building it way longer before I got inside of LLMs, actually, because I was in all these open movements. So I was in Wikipedia. I was in open science. I was really activist at the time, a bit like the time where Aaron Schwartz had all these issues. And I even leaked the Soviet contracts and stuff like this. So, and I was kind of close. I was doing my thesis on text mining on public domain corpus. So I know so that there was this large giant cultural heritage datasets that were kind of flying around. And so I would say it really started the idea in 2020, so very early when, we started to scale basically. And before that, actually, it was kind of more commonplace to like Wikipedia that set I could release. But suddenly, when the scaling began with GPT-3, you had this big crowd data set. And effectively, the GPT-3 paper was almost the last one, was to really detail the data sets they have been using. So, and suddenly there was this kind of discourse, but it's completely impossible, to train on data that you can release because it's the right size and all these things. And immediately sounded off to me because, there are issues with ethical training, obviously, but size not necessarily, or at least definitely much more than you believe, actually. You can definitely scale to a large amount, enough to basically create almost a pre-training ecosystem. So it really started the journey there, and actually it was the original journey of Pleias. So now we have kind of expanded a bit in the other direction, especially static data, but that was really the original impetus. So Common Corpus was our first project. We started it around public domain originally, so everything kind of digitized cultural heritage because it was really like really big sources actually, which were kind of not being collected or curated. And gradually we expanded it. So it was more like a continuous project, which is a bit different from a job project that was also undertaken around the same period, like Common Pipe from Eliota, which was more like, okay, there is a one shot and a lot of work. Here we worked very gradually, aggregating other things everyone passing by, so there have been multiple updates. And so I think the aggregation was like 2 years, and it involved a lot of work in terms of provenance, I would say, which is really the kind of different outlook than when you just take a crawl. Because when you take a crawl, okay, you have this kind of agnostic crawler going through the web, and then maybe you try to filter afterwards. Yeah, it's kind of the reverse because you start from a situation when you have to know already what you're going to find, and then you go in depth on these sources. Because what we discovered is that right now there is less than 2% of Common Corpus which is inside crawl dataset. A very tiny amount which is being in both sides. Because if you just do filtering of crawls and you take only the part which is the free license, you have very, very little amount. And the reason for this is that crawl as an infrastructure is kind of faulty because it does not archive PDFs. It does miss a lot of content because everything that is kind of not cross-linked, because the crawler by definition has to crawl, it has to move to one part to another. Anything that is not being indexed, it's a large amount, especially for anything that is large data set, like large digital libraries type of things that are not being indexed right now. And so actually in a way, and especially for the global soft content aggregated, we have now almost a role of preservation because a lot of the data we've been aggregating actually have been either high risk of disappearing or already disappeared. Like, for instance, the big changes that I've mentioned, it had been collected thanks to two seeders that kept it on torrent because it was all kind of open data, Chinese, case law, and stuff like this, which the government stopped opening basically just during the pandemics, even though it's open data. But there was no institution, no place to keep it. So you really have to do this kind of investigation to actually create open data and maintain it, curate it, and put it back into a place where you can create. So yeah, there is a collection part, and there is a processing part. And one of the biggest challenges is that most of it is PDF, which is a big difference with web sources, which are HTML, which comes also with their own challenges. But with PDF, it means, okay, you can have OCR errors, you can have this type of thing. You might want to correct it at posteriori. You might want to digitize. Now we digitize a lot now, especially scientific data. We have our own pipelines with visual language model for this. But yeah, it's a different approach. The nice part is more on the side of, for instance, context length. Like, you get much longer documents through this, which is kind of interesting. Plus, not only longer, but better contextualized, because we get a lot of metadata about these documents. We know the authors, we know where they've been published, in which date, in which context, this type of thing, which is not what you have when you have a web crawl. Usually, you just have the URL, the moment it was collected, that's the end of the story, basically. So my hope right now, but I'm not sure it's going to happen, but that's going to be more interest in open data for this purpose, especially in the context of agentic system, where you are more interested in content which you can trace, which you can know about, so that you can train model to be good at search, to be good at all of these things. So it gets more value, basically.
How important is the harness, in your opinion, with running agents and going forward for synthetic data creation purposes, where there's a huge demand for agentic data that helps models perform better in common agentic harnesses, Claude Code, Cursor, Open Code, Codex, etc. How have you and your company been responding to the kind of latest development in demands for synthetic data?
So I think it's kind of a new development in a way for synthetic data. The approach we had used originally was more about fine-tuning model, which was kind of unusual, because usually when you do synthetic data, people will just take an existing generalist model, prompt it at the end of the story. Whereas we really wanted to have a high level of control, for instance, even on the style of reasoning, how it's being structured. So there was very specific steganographic style we put inside of SYNTH, which is something which is very, very complicated to get if you just get prompting, because it's too much. You ask for questions, and you ask for styles, and you want for other things, and so on. And I think there's still now a need. We have been very interested, especially in recursive language models approach that are being pioneered recently to basically, create agentic traces in a kind of recursive way and deeper sequences of things, and especially using agents also. And that kind of loop back to the previous questions for data curation and data processing, because a huge amount actually of work you need to do to get good static data is actually seedings. You want to have good sources of inspiration. You want to use, you want to ground things basically, because it's always based. So grounding can be kind of elaborate, because you're not bounded to just use the text. You can definitely use structured data. We use a lot of Wikidata for this, for instance, or you can use any kind of information you want to access. But more and more, we are in a situation right now when we want to get, and I think that's really the future, where we're directing ourselves, not really our pipeline as it is right now, but more and more this kind of process of curation, this kind of process of deciding even what is the interesting task we could create, what is the interesting static environment we could create. But this process will have to be created by models themselves at some point, because that's the only way you can scale. Because if you start to minutiously construct it, okay, this environment and this and that, you can do it if you're large labs and you can ask for millions of people doing that. It's not something which is possible right now. So we need to find a kind of scaling perspective. And the harness can be definitely useful. I think the other part is also about, I think it's really the concept from Ilya Suskier that I liked, which is called training on deployment. Because once you have a good agentic systems are already something you want to train on, but they can get the model better at it, better at understanding, okay, what is infrastructure I'm currently bundled in. So a lot of the thing we're working right now with our partners is how we can adapt what can be the MCP, but even straight the API system in such a way we can simulate it and create kind of good harness for it first, and afterwards use it for simulation, and then it loops back to we can use it. But no, I'm not seeing really. Definitely seeing the harness as something that is going to be more important in the months to come, even for static pipelines.
And how you think about evaluation? How you evaluate these data sets? Because there are so many works about the connection, right? Or how you actually want to evaluate models during pre-training, right? So how you evaluate the quality of the data? You have two problems, two different axes here. One is what actually the the metric for the model, right? Like when you pre-train, like do you measure only on the post-training like metrics? This is like one question, and the other is like at the end you tie to a model, right? Because like you have the data, and the only way to evaluate, or like maybe not, but like a reasonable way to evaluate it is like to train a model and to say, okay, this model like is good or bad with this data, but it's only like one specific model. So what's your thought about it? Like, do you need like several models, several metrics?
So the approach we have been using for static pre-training, which is interesting, is that we can train from the start with reasoning traces, which is kind of nice when you want to basically not just use a kind of very soft metrics that are being used in pre-training, like LSWAG, this type of thing, which just, okay, the model is kind of having a broad common sense or linguistic capacity, but more you want to measure reasoning capabilities from the start. And here our big inspiration was especially the work of physics of language models, and the idea, okay, how we can basically assess capabilities from the start and even start thinking in terms of selecting, for instance, doing architecture choices for targeting specific capabilities from the start. So the approach we have in SYNTH, and in the paper we have been preparing for SYNTH, which is not, I would say, out yet, but soon, is really about, okay, we kind of have a collection right now of about 45 different evaluations in different domains, especially specialized domain, because we want the model to be kind of broad, well, as we say, more boobas and kiki, basically. So having not just MMLU, but really all kinds of capabilities. And we see basically, and it was really interesting for SYNTH because it was already a scaling bet that we take all the vital articles of Wikipedia, but it's kind of a good condensation of most of human knowledge, even kind of specialized. So it's not just, okay, it's good at MMLU, and then you could say, okay, it's circular because MMLU obviously is measuring high school capacities. But what we have been seeing instead actually is that the model is good also even for more specialized telecoms domain, this type of thing. And the nicest part, really, we show in the paper is the fact that we have reasoning traces to assess this thing, even for small model, basically. And what we saw, especially, it was really interesting, was we saw basically an emergence of the model capacity to correctly assess in certain uncertainty. Like, for instance, stating, okay, I'm not really sure about this information. And because we have this in the reasoning traces, where the model can memorize things and say, okay, I'm kind of circling on this specific domain or specific topic. And then what we saw is that the smallest model, basically when they were trying to edge or whatever, it's not really making sense. But the larger model, when they were trying to edge, definitely it was making sense. It was kind of connecting actually with what they knew and don't know. So it is the kind of thing, basically, that does really allow to have a closer, I would say, outlook of how we can. I think also an advantage also working on SLMs is that complete pre-training is kind of relatively fast, even more so with SYNTH. So we can definitely make decisions at this scale, but we can definitely assess this. The other side of evaluation, which is really important actually, is with our clients, because the big issue that we have, obviously, is the fact that what is relevant as evaluation is not necessarily going to be available. So here, there are two different situations. Like, for instance, it can be that, for instance, some industry decide to create an entire evaluation suite, which was the case with GSMA. So they have this kind of big telecom benchmark. They have been releasing with 6 different evaluation systems. So it can be knowledge, it can be analysis of logs, this type of thing, which we have been using. And what was interesting is that they showed that basically there was very little improvement even for frontier models on their evaluations, because it's not the kind of thing that is being targeted. But the other interesting collaboration we had was especially that, for instance, for the subway models, it was basically our client that designed the evaluation itself internally with travelers and everything like that, trying to assess already what is working or not. So yeah, I think evaluation is really like a key skills you need, not just using existing evaluation, but building some actually are really needed, because in the end, it's really the target you're going to have. And that's what the frustration I got right now with a lot of models we call, okay, they are kind of benchmarks or whatever. It's not just that they are bad, but they are targeted toward a specific use that is not necessarily going to meet the variety of even the intent, actually, because a model can be kind of limited. Range actually is fine, especially if you make a small model designed for a specific industry, for a specific use case. But within that, it should work relatively okay. So yeah, there's a lot of intuition that have to come into this to be able to design it properly. Yeah.
But do you think like at the end from pre-training data, like we want something more like general, like that like will be good for different domains, or like we want something even for pre-training, we want something very specific?
I think
like
yeah.
some domain together?
I think that's really the key thing. We wanted general. So definitely for instance, MLU and this type of thing, okay, that was kind of the primary objective we had. What was really interesting is that we got good results on this kind of specialized or semi-specialized, because sometimes it's not necessarily advanced knowledge, but all kinds of evaluation we have been collecting through the existing literature in all kinds of domains, even some where we don't necessarily actively worked on. But for instance, it turned out the model we were training were really good at things like petroleum, for instance, this type of thing. So we had no idea of what is really inside, but it turns out, just drawing from the knowledge we have put inside of the model turns out to get the model better at it. So I think we need both, because especially I think it's really interesting to use specialized evaluations in domains you're not necessarily familiar with, because it's a good warning in terms of, okay, your model is definitely getting better at something else you're not necessarily anticipated. And I think it's a larger issue, because right now I think the system models are so complex, especially if you want to get toward agentic models. There are so many things you can do, so many environments you have designed. So you have to think at some point about something like a generative principle. It's like, okay, you want to generate the universe of possible environments, which you cannot control by definition. So that's why it's super important to have this scope of evaluations, which is not limited.
And in general, I think you mentioned as part of this, the term benchmark, like maxing, right? Like people kind of over... Yeah. How do you fight that? And in particular, I guess the second question is, if you've had any experience with GLM 5.2, do you think that they're also benchmark maxed? Because they, like everybody else, seem, people online are like, oh, it's an Opus class open source model. And I just have never seen that with any of these even big Chinese models. So I want to hear your opinion.
Yeah, I think it's a very good question, because I think it's right at the heart of whether or not there is a big lag between open and closed frontier models. And I think the biggest issue for the lag is the fact, obviously, frontier labs, they have their internal evaluations that are not open, that are not public, that are not all of these kinds of things. And I think what also goes in the direction of the lag is the fact that we have almost a market mechanism right now. People are definitely voting for closed source model. We can say right now there's been a big catch-up of this kind of open model. A bit now DeepSeek for pricing reasons, but not necessarily for capabilities. So definitely I think it goes the direction of the lag. And I think the reason for it is also that we have been having also this cycle with reinforcement learning and with synthetic data that didn't make it really hard actually to climb basically an evaluation. So definitely, you can benchmark in specific, but then whether or not it's going to give you a kind of broad ability, and whether or not you're going to cover all the range of use cases that people want to do with it, and even if you're not going to harm it in the end, because that's the issue. Sometimes base models are better for a wide range of use cases, but you're going to break it during post-training, because suddenly you make that's the thing actually we saw with some even synthetic datasets. I'm going to name some, but are on the gig phase where, okay, models trained on it, they are kind of better on the benchmark, but they're completely broken if you are using it for anything other than English, for instance. So I think it's really about this kind of equilibrium, and also the part where it's kind of interesting always to think of model for deployment. So what is a thing I do all the time when I'm training a model is just reading the outputs. Like I have my set of questions I'm going to ask. I want to get the feel of the model. I want to get an idea of how it's going to behave, even in a kind of more adversarial way. And it's obviously it's very non-scientific, I must say, but I think it's not really that dissimilar to from what I hear frontier labs are also doing when they're training a model. They want to get this vibe, of, okay, how the model is kind of behaving, even in a way which is completely orthogonal, unrelated to any kind of benchmark optimization, but you want to get basically this behavior right.
And do you think like there is like, I don't know, some specific data types that will be more like, I don't know, robust to benchmarking, and versus data types that are more like specific and like you can actually like climb up on some specific domains?
I think the case, but I realized I haven't really answered you about GLM 5.2 because I'm right now trying to deploy it for static data, and because I've been seeing all the interest for it, and I don't have the answer yet because I haven't tested it enough. But I think it can be pretty interesting because from what they described in their paper, but again, to be seen whether they try to make basically this idea of generative static environment, which is also something which is really close to my mind. Like, okay, you're not really just going to uncraft all of these things, because also for there's a cost issue, obviously, but I think it's also the issue of how you can cover a wide range of things. But you're going to try to generate the task, generate the range in a kind of expensive ways, in such a way that you're going to cover much more information. So, but yeah, I think right now it's a bit difficult right now to say it's just about one piece of data that are going to allow to you to overcome this, because anything can be reward, anything can be a climb. So it's more about a good practice, I must say, of ensuring diversity of even the targets you're going to have. That is going to help you out to overcome this benchmarking, I would say. But I think it's also about what the models you want, basically. Because for some organizations, definitely, they're just fine with, okay, they want to get good benchmarks at the end of the story. So they're not necessarily going to be interested in actual deployments, which is not really our case. But yeah, it's more about the practice of things.
And from, when you're talking about like diversity with synthetic data generation, what are your favorite ways to improve that? And what do you think works best for improving creativity diversity?
So it's a very, very good question, because it's a lot on my mind. So I think first, obviously, it's going to be seedings. You don't just want to prompt a model, because that's how you're going to get diversity collapse. So you want to get some alignment with other things. But then on top of it, you might want to control for the model behavior. Something that was actually pretty well for SYNTH is that we had this kind of control features that we use to basically ensure that we get a range of combinations. So for instance, the fact we want to ensure that the model has at least 20% of questions that are going to be negative, like going to elicit a refusal, going to be absurd, because it helps with getting the right word models. You want to get also, for instance, all kinds of inputs that could contain, for instance, typos, all kinds of diversity, to basically increase the surface area of what the model is going to meet. So I think that's one of the first thing. But then what is really interesting for me right now is also how you can create even something more diverse than the kind of organic sources you can access to, which is something which is very interesting for me. And really at the source of the collaboration we have with NVIDIA, which is about creating synthetic personas. So the core idea is how we made that for France. We have been their partners there, started sooner with the US. And the core idea was really about how we can model the demography, so that you can get realistic persons, which are kind of the right combination. So we use a probability graphic model for this, basically, is that, okay, you start from a region, then obviously in this region, there's a lot of old people, for instance, and then since they are old, they're not going to have a large educational background, for instance, are more less likely to be immigrants, all these kinds of things. And what's interesting once you got that you can get basically also seedings for a lot of people that are not going to necessarily, for instance, write a lot of text. Like, it's not going to be that presented in the quotes. It's even more important because it's the kind of approach we also exported even for our project in Africa. We have made some personas in Senegal, this type of thing. And it's a lot, again, of people that are never being represented in core data sets right now. So I think it's kind of interesting, this kind of approach, because it goes a bit against the grain where, okay, stick data is always thought, like power representation of the thing you're going to get into organic data. But my belief right now is that if you get your pipeline right, actually you can even correct some of the bias. You can even enforce some presentation and say, okay, we want it, for instance, this environment to be from the perspective of someone, let's say, in Senegal that are going to have health issues and so on. And then obviously there is no hospital open whatsoever in the region. How do they manage and how to get access, for instance, to a chatbot service? These kinds of things right now, which are not being really simulated. And obviously it's creative, so it comes with risk because obviously you're doing simulations, but in a way which I find very, very interesting.
Interesting. Do you think that model distillation attacks and similar kind of problems are like actually reduced, or by reducing like thinking trace visibility, as we've seen from like Claude Code and Codex and the closed source model providers? They're trying to hide the thinking traces. So I think you alluded to this earlier as well. Yeah. What's your opinion on that?
Well, I think I have a bit of I would say controversial idea around that, because I definitely see as a way right now for large model providers to put some kind of intellectual property on the model outputs right now. So it's something which is complicated on the perspective because obviously they train on all of the web. They don't really ask for permissions. They push really hard for fair use. And then suddenly we start to see this discussion even about model IPs, which is now being mentioned. OpenAI recruited someone to deal with our model IPs. And this idea of distillation is kind of a way to have a claim of intellectual property and synthetic outputs in some ways and to prevent people to using that. And so I think obviously there are a lot of economic interest around that. And I see the point because right now we have been seeing this maturation of AI. So now there is this need of, okay, they want to protect the output. And I think it's something we're going to see very much push once the model would get clever enough to create actually very powerful output, which is not really the case yet, but what we have been seeing with, okay, models, for instance, that can solve complex mathematical conjectures, this type of thing, we can get into very fast into a situation where even model could make scientific discovery and then ruin the patterns, this type of thing. So we're seeing kind of this push right now. And I think that's why it's really important, but it's not done, for the open model community to kind of step up its skills in terms of synthetic data generation and curation, because just pure distillation in any case is kind of putting the ceiling in any case, because okay, you're not aiming to go further than the model you're targeting for, which is already why it can be pretty powerful obviously if you have a very small model, but still it's going to put you a ceiling. Whereas if you have this kind of good process, you kind of train models for this, and you put a lot more information that were available, for instance, the quotas, this type of thing, you can definitely go beyond the existing capabilities. And that's how basically you can create this kind of open ecosystem I would like to see at this point. So yeah, I see it more like an emerging conflict I'm seeing right now between, okay, there is this large industry which has its own interest right now, obviously, to close things down, which makes sense. But on the other hand, this kind of newcomers, definitely in China, but also hopefully maybe in Europe, which are going to be more interested into the side of, how we can pull even our efforts together to create good data practices that are going to allow us to get competitive, not necessarily at the frontier level, but at least on some industrial application of AI.
And what do you think about pre-training versus post-training data? Do you think like we need specific data? It can be, I don't know, synthetic or like not synthetic, or like what people are doing with their environments, our environments these days. Like, so do you think like do we need some specific synthetic data there? And like, if so, like, what are the paths to a good data?
So I think I think it's a very good question, because I wrote one of the first, I think it was almost the first blog post on mid-training 1 year and a half ago. And at the time already, I had this suspicion, mid-training is basically about scaling post-training. So basically at some point I want to create much more environment, much more data, much more memorization and stuff like this. And my suspicion already at the time, which is actually the thing we've made with SYNTH, but which is basically synthetic pre-training, that, at some point, if you continue to grow these things, is it not actually what you want to train on? And I think right now we have this kind of divide. It's kind of unknown whether or not we're going to go this road, but definitely we push forward this direction where what are we actually modeling for, actually? Is it just language? Or is it more like infrastructure, knowledge, particularly any kind of complex systems you want to model? And I think our joints are kind of moving in this direction. And should we really wait to have a complete pre-training before we start doing the thing which is actually interesting for us during mid-training, during RL, doing all of these kinds of things? So the idea we pushed actually with SYNTH was really about, we want to train directly on reasoning traces. Zifra did the same thing in their latest model too. A few others have been doing that, and I'm kind of suspecting even Chinese labs. So from what we can gather from Moonshot, I think they also did something a bit similar in terms of putting a ton of synthetic data, likely with stick reasoning, very early in training, and then you can get basically. I think it comes with the direction again of scaling, because once you get all these environments you're going to create all these kind of agentic scenarios and stuff like this, and maybe suddenly the main entry point with the model is not going to be a chatbot, but really the kind of thing you have with cloud code. Then, obviously, if you're interested with cloud code, your reasoning is going to be generated by definition, because it's not something which exists in the real life. Intelligent reasoning never exists in the real life, so you need to generate it at some point, or you need to create it to create the condition for it. So my expectation right now is that, we're probably going to have this kind of a break where what used to be pre-training is going to collapse into something else. So actually, that's the title of the paper we have submitted not long ago for SYNTH, which is called It's All Training, which is really about this collapsing of, okay, maybe we don't need to separate right now between pre-training, mid-training, post-training, and okay, we can collapse it all. I think it makes at least a lot of sense, at least for small models, to be seen whether or not there are still some benefit to start with a large training of unstructured data first. Again, maybe for diversity purposes for large model, but at least for small models where you really want to target as much as possible their efficiencies, their use for applications, and it's okay basically if they are not going to be having a large breadth. It makes much more sense.
And do you think like these small models like can be competitive to larger models?
So I think it depends for which
at least in like narrow domain.
Yeah, exactly. That's basically what we did for the subway of Paris. It's a model in production right now, so it's not a POC, and it's being used actively for the monitoring system. So it's very tiny, 600 million parameters. It does its task. And I think we're going to see a lot more of this because I think actually for some of this kind of tasks, small models are good almost by design because the nice part is that it can be very bounded. You want them not to go all over the way. Like the issue actually we had seen with a lot of applications, for instance, in the early days of ChatGPT, where, like, for instance, a lot of people were creating a commercial chatbot, but then you can ask all kind of questions, it will go off rails. Here you can get much more constraints. You can deploy it even offline on safe infrastructure, and it can be really models for infrastructure. So I think that can be the first push. The second one, which is a bit more speculative, but I see a lot more interest for that, is whether or not, for instance, we can get a market for sub-agents, for instance, because we see kind of the emergence of these needs. I have it very frequently that, okay, I'm interacting with Claude, I'm interacting with Opus, but then suddenly I need to annotate, for instance, a large corpus. So it can use Haiku for that, but it's really awkward. It's not really being well done right now. And for instance, I want to authorize something. I want to, let's say, interact with the documents. I want to maybe access Wikidata, for instance, to do some search. All of these kinds of things, they kind of call for actually having this kind of specialized model, and large model could be the ideal orchestrator for this, because I think the reason actually good specialized model, because they do exist, never really took off, is really also the mental cost. You have to know they exist, you have to use them, you have to deploy them. But if we are in a situation where it's kind of smooth, because, okay, there is this kind of large model doing the orchestration already, and maybe, I think the issue is that large labs are not necessarily interested in this approach right now. But I think it's definitely the kind of commercial model that could work out, where you could have all kinds of specialized provider, especially if we are in a future, for instance, where our training recipes are much more distributed across a lot of many industries. Yeah, they could make available all kinds of sub-agents, and you could have shared retributions or whatever you can imagine for inference cost, and you can have particularly this kind of healthy ecosystem. So there's kind of the two directions. You can have a very large organization for their internal purposes. You need to have their own systems. And also for another reason, actually, we had not really anticipated, but I see a lot right now, is really companies getting concerned about their IPs, about their own capabilities, about what actually they have to defend in the long run, and they see basically AI as a general transformative technology, basically at this point. And okay, if you get everything automated, even for an external system, actually it's not that great at some point. You want some defensibility. And also you want to ensure also you, in some cases, especially in the regulatory sector, maybe you want an external actor to access what you have. So you want to preserve it. But even more deeply, it's really about models as, something which is part of your technological assets.
And are you seeing a big movement and desire for more stuff around cybersecurity now with all the hoopla around Fable and Mythos and related?
Totally. I think it was been the actual wake-up calls, because we had many in Europe at this point. There is one almost every few weeks, but I think this one was kind of genuine, because suddenly they realized, okay, there is this kind of big strategic mess. Like suddenly, it's not just about not accessing the latest chatbot, but basically we know that our infrastructure, banks or whatever, well, they are not going to get protected for any kind of assault. They are going to get definitely there's a real concern about this right now. I would say the real unknown, but I don't have any kind of solution right now. And there's a lot of speculation around that, whether it's something that comes for pure scaling capabilities from generalist model. In this case, okay, it's going to be pretty hard to compete with frontier labs. Or it's something which is more in the direction of specialization. I think the signals from frontier labs are kind of mixed in a way, because I think they are getting pretty good at things they are knowing in the end. Like, again, counter example is telecoms. Evaluation has not been progressing for 2 years because that's really some things they are interested in. Whereas, okay, math, cybersecurity, computing, okay, they have internal capabilities, you know about these things, you know it pretty well. So they can push the model pretty far in this direction. So I would say it's kind of a real unknown, but I think it's also the general issue also of information asymmetry between what we know labs are capable of doing, whereas what they actually know. Yeah, so I think it's kind of an unknown at this point, but definitely we're going to see this push. The key issue, at least for Europe, is really about the fact we don't have a large amount of labs that even have the capabilities, even to train not just frontier model, but even like capable close to state-of-the-art model. It's really something we are kind of lacking. So definitely it creates a lot of imbalance.
And I have another question. So like we talked about like orchestration and like small models that can like I don't know make some like joint decision. But do you think we actually like need the bigger model, like a general bigger model to orchestrate between them? Because like it looks like a lot of people are trying to do, a lot of companies are trying to do this orchestration, right? There is like, for example, today or like yesterday, so Sakana AI, right?
Yeah.
Like making like some, make a orchestration level that you call different models, and the idea is that you try basically to predict like what is the best model to do this task or like to do the next step. But do you think we can come up like with like specific types of data that actually like make it easier, like more like, or like even better than general models that like just train on all the data, or like the general purpose models?
Yeah, I think it's complicated because the key issue is really about beta lesson in the end. And the advantage of large model that you don't have to have a classifier, router, or whatever, because the model is just knowing already what you want to do. And that's the actual reason, because we really see the click, I would say, around 1 year ago, because before that, Opus was not the most used model at all. People were using Sonnet. And Opus was seen, okay, it's kind of clunky, it's too big, it's not being deployable enough. And then suddenly there was, I think, both the fact, okay, Opus inference got better, but on top of it, there was suddenly this kind of need for more complex use cases where you want to get an understanding of things. So I think right now it's a bit different. The kind of vision that I have, it's more about, okay, either models that can delegate some things at some point, but I think maybe we need to still have this kind of model orchestrator at some point, which is going to say, okay, this is going to be the intermediary I'm going to be using. And then, on the contrary, because I think Sakana approach is more like, okay, they use a very small classifier, which is going to route you to potentially powerful model, which I'm not sure is the right approach. I think it's better to start with very large model, which has basically this good understanding of what you want to do. And then it can push for, especially if you want, for instance, to analyze a large amount of corpus, large amount of text. Today, models are very reluctant to do that, actually. They're really reluctant to look at the data, which is my main complaint with them right now. But we can get even better capabilities in the end through this kind of orchestrated process. So I think it's really the selling point at some point, not just to get something, there is the issue of cost, obviously, but still, if you can get systems that are better than the one that you have right now, I think it's kind of good. There's a question which is actually more interesting and more frontiery in a way, which is how good can you get a general agent, basically, general capability model, like even like this concept of this concept of cognitive core, which is one of the inspiration actually we got for when we created SYNTH. Even though we revised it a bit because the core concept of cognitive core was really a model with almost no memory, but just the ability to know basically where to find things. And what we discovered actually through our approach static pretraining is that, the model needs to have some memories. But general intuition that we have right now is that, again, the information that we have as a person is not that big, again. What we have seen through all our life is not that big. And quotes that are kind of very lossy. So I think there still could be the general bets, especially if we get maybe also a better knowledge infrastructure around it. So maybe much better API, a better way and smoother way to access information. Maybe we could get actually a good enough actually general intelligence, because I think sometimes we kind of forget also what was general intelligence. Not necessarily are going to be about someone knowing all about everything, but having kind of the cleverness and ability to find information when needed. Maybe this kind of general intelligence doesn't need to be that big. I think I still need to have some size, definitely. But definitely, I think we could get, and I think we see this demands. I think it could be something emerging, like we have seen like this kind of 30B model getting pretty good right now for many tasks. And I think even more with specialization, we could make very good almost like personal agent, like, okay, the kind of, because for this, definitely it's a use case where you don't necessarily want to send all the information to a bit frontier model, and you want actually the model to be pretty good at accessing, for instance, all the information you have on a computer, all the information about yourself, your life, whatever, in a kind of very smooth way. I think that's kind of the use cases where not necessarily big, but generalist model could be pretty useful. And definitely the kind of thing we don't see yet, but that's kind of shapes of model to come.
And what are your opinions on the politics of models right now in terms of like the countries kind of leading the pack on AI development? So, for example, France has at one point had Mistral, which was held in really high regard, but there has been some people claiming Mistral's kind of fallen off, and now there's this push around sovereign AI across basically every country that's not the United States. What do you think about that like the geopolitics and how it intersects with these models and the development of them?
Yeah. So I must say I'm very, very ambiguous right now with the notion of sovereign AI, because the key issue is that, okay, first it creates fragmentations, and then it's not necessarily very conducive actually to even emancipation, because my own vision right now, I think even for Mistral, it has been kind of an issue at some point, because they have been kind of pushed direction where, okay, they are the national champion, but then they have to be super focused in becoming something a bit like actually a big French consulting firm to many extent. That is, that I spend much less time right now reading frontier model reports and much more time, going through all the big French administration, kind of optimizing their workflows, which is not that conducive to a kind of research spirit, like you're not getting, and I think as part of the discourse on Mistral, I think Mistral is optimizing for what you want to look for, which is definitely going to get good at corporate business in France, but they're no longer optimizing for being a frontier labs right now at all. And they're kind of open about that. They're not even hiding it. So I think that's kind of the issue. But I would say right now, my vision more and more is not even about French AI, not even about European AI, because I'm kind of very skeptical in the direction right now taken by even the European Commission in terms of the expertise that they have internally is very poor, and they're not making good policy discussion. I think what we need is more like almost like international coordinations, because we see these concerns right now between, there is US blocks, there is Chinese blogs, which seems kind of more open, but we can't know for sure. And there have been kind of mixed signals even from big Chinese labs. They start, for instance, to remove free license for the more powerful models in some cases. So whether we can rely on that is not that obvious. And I think it's a shared concern, not just with Europe. We see it also, Korea has a pretty good program right now for developing their own training capacities. But Japan has Sakana, we have mentioned this before. There is India even with Sarvam, which definitely has been training models, which are not that bad. Also, all this kind of basically innovation, I think it's really called for having this kind of international community where we share knowledge about AI, and we share in a way where we can practice AI, which I think is right now the most lacking thing in Europe, really. Because we had actually this time, there's always the idea that in Europe we have the talents, but I think it's no longer true at this point, because all the talents that we have were kind of trained, in the kind of pre-LLMs AI, so they're pretty good at it. But what we have right now is the current practice of LLMs, like even how you do, for instance, agentic evals, how you can deploy very large mixture of experts, how you can train that, doing all these kinds of things. There are very few people in Europe doing that right now. And I think it's kind of becoming a concern that we're kind of lacking the practice. What has been working the best, I would say, right now in Europe is really the concept of big clusters, which is actually even working better than the US, because I see a lot of people in the US in universities are kind of frustrated because they have very, very little access to compute, and the local clusters, and that's great. Here, at least in Europe, what worked great, because it was kind of an investment being done almost 10 years ago, not even for LLMs, but really for kind of shapes. Even for the project, we do have this kind of much smaller, obviously, than frontier level cluster, but still sizable clusters in France, in many countries, for this kind of specific things, which is right now almost the only place where we do practice, where we do distributed computing at scale, this kind of thing. But that's where it's complicated. I think really it's kind of the most pressing concern right now. So the reason actually we joined this project from Islands called Tapestry, which was launched by Yann Lequin not long ago, and we are one of the stakeholders in this, which is basically a place also to get this kind of exchange of information, experience, and expertise across different countries. In AI.
I want we don't have a lot of time, but I just have more questions about scaling laws and what you think. So till now, right? People have built scaling laws and how the model will performance with some some amount of data and when you scale the compute and the interaction between them. But do you think when we control the data, we can have more I don't know, smarter ways to build these scaling laws? For example, you can imagine that you need different types of data or data properties when you have small amount of data versus when you have large amount of data, right? So it the kind of the sampling is not a IID, if you want, when you scale it. Do you agree, or what's your thoughts about it?
Yeah. No, I completely agree. I think one of the most interesting things we have been discovering is obviously scaling laws are completely true, obviously. You want to scale the models, and scaling across different dimensions, obviously. It's not just about number of parameters, but it's about diversity. It's about the amount of knowledge you want to embed. You want basically this kind of scalings, but you want to do it intelligently. I think the most important revision is that a lot of scaling laws were kind of conceived for one specific data source, and which is basically web crawls originally, which is much more specific than a lot of people believed at the time, because it's collected in a certain way, certain texts, which are mostly very short, because again, everything was kind of dependent on a common crawl and their infrastructure issue at some point. They were not having money to collect PDFs, so obviously we don't have PDFs. So even in terms of coverage, where there was very little multilingual sources for various reasons, so everything was kind of made from this perspective. And what we're seeing right now, when we can train a model on static data at scale, is that scaling laws are definitely there, but they are behaving differently. We have much less issue of stability. A lot of batch issue and spikes and stuff were mostly due to curation issue in terms of how you're going to get the data. And we can very, very closely inspect that. And yeah, what's interesting is basically I think how we can even compile, for reasoning at some point, how we can get the models to get certain capabilities to unlock some capacities to solve math problems or whatever. You can observe that in a very minute way. And yeah, the inspiration is really being physics from language model with the idea of controlled environments. Okay, you know exactly the data shape you want to put inside of the models. You want to see basically how it's going to adapt to it, what kind of thing it's going to memorize, what kind of exercise, for instance, multi-op reasoning, this type of thing. You can really abstract it, and you can see how the model can gain that under different conditions. And I think it's very powerful as a kind of approach. I like it a lot because I think it's much more scientific than what we did before, which was treating data like an opaque box, and then And now, I think we're really at the start right now, at least in the open. I think probably this work was done in the closed labs already. Maybe it's a possibility. But at least in the open, I think we're really at the moment where we start to be doing proper scientific work on this scaling laws, intently plural. And there are many things we still don't know in terms of, for instance, what is the right amount of repetitions you need to have for rephrasing, for instance, something we don't know yet. What is how much time, for instance, you need to repeat a math exercise until the models knows it at a given parameters, budget, we don't know yet. This type of thing right now, and I think it's really exciting to be part of this because there's much more experiments we can do now in a very controlled way, very scientific, very reproducible way. Also, since we can open the data and with static data, we don't have the issue of, it's kind of awkward, we don't know where it's coming from, maybe there are some liabilities. So I think it's kind of exciting.
Okay, we almost out of time. Maybe let's talk a bit about the non-neutron personas data sets. What do you want to maybe to explain a bit about it, and what are what is the goal and what's your role in this process?
So It's a project which started by NVIDIA, but even before that by Gretel, which is a synthetic data company which was bought by NVIDIA about, I think, 1 or 2 years ago. And the core idea was really similar to us. So we're working, a lot of people, for instance, in insurance processing, in banking or whatever. And the key issue is that, again, if you want to train models, you want to exchange data, even for doing any kind of thing you can imagine, you have the issue that, okay, you're going to train on forms, for instance, shared by a person, but then they put a lot of information about themselves you cannot really share. And it's a general concern started in the US, so it's not just about GDPR or whatever, and it's a general concern about this domain. So the core concept of personas was originally born from this kind of concern, but I think it grew beyond that because it's used a lot right now for static pipelines in general. Because, as I mentioned before, it's a way also to create more diversity, to create also even situation, especially in agentic systems, because you want a user, but you want to flesh out the user. It's not just a random person, but maybe it's someone in a specific place, specific case, with specific ideas and so on. So the personas originally are really made with this idea of, okay, we can simulate demographics, and demographics of the US is very different from the demographics of France. And one of the key parts, for instance, is even the kind of information you can access. So we're using open data usually, and at least in France, we are kind of very lucky to get a lot of information. But even then, it's tricky because, for instance, at least in France, we don't have any kind of good recording data for people who were becoming French, basically, like immigrant, but first generation immigrants, because they're not being born there. So they're not being traced at all. So we have to correct for this to be able to kind of reflect better the population. We use statistics and with corrections, this type of thing, to be able to correct for this. And so NVIDIA had this program started in the US, then they expanded it, I think first in Brazil, in Singapore, I think it was the 4th country in France. Then it continued, and now we are the 10th country for Belgium, which was an interesting use case because it's a multilingual country. So we had to generate data in French, Dutch, and German, and we had to ground all of these things. I think really the common thread is this thing. I think it's really about how it kind of connects what I was saying before about international collaboration, which is how we can create these shareable assets for data pipelines in AI. Because at some point, if you get good personas data, is a kind of general purpose asset in a way, because it's the kind of thing you can use again for alignment. You can use it again for just fleshing out any kind of static data. So you kind of need that. So yeah, that's I think also interesting. That's also the kind of thing we don't necessarily going to require actually large scale compute, because we did that actually on Janzé on national sovereign compute, because all the part about simulation of metadata is done just with the PGM, so it's a very, very light model. I can write on my computer to do millions of rows in a blink. And then, yeah, we kind of create this kind of fictive biography people can use or cannot use, basically about, okay, the person, where it is, what it's coming from, and so on. There's a lot of interesting research to be done still, because one of the issues we found that even with the control of, okay, the person where it's coming from, model can still collapse a bit in terms of, for instance, the diversity of taste. Like, okay, at least in France, like, okay, all people are reading the same books. All people are kind of having the same taste in kitchen and so on. So at some point, you have to kind of extend probably even the range of features you want to put inside. But yeah, I think it's like, what I like is really about data, the kind of never-ending project, basically, at this point.
But the idea is like to
better.
what? Like now, given this data set, I can, what are the goals? Like what I can do with that? I can like sample persons, and then I do some like survey about something, as like instead of like asking real people, like to learn some demographic kind of shift. So like what do you actually do with these types of data?
I think there are mostly two use cases. So the first one is really about, again, simulations of sensitive data, because it's a ton of personal data, and you want it to be realistic, because you want, for instance, if you're going to train, we have a project right now in insurance filings in France. So it's a lot of people writing complaints about, okay, for instance, there was an accident with their cars or whatever. They put a lot of information. They put their address, they put their names, put all of these things. Now, if you want to train a model on this and you want it to be able to afterwards being able to process real information, you have to ensure there is this kind of alignment where the name of the person, its age, situations, choices they could have made, because they all impact afterwards, even the case, what is going, for instance, to be the monetary situation, all these kinds of things is going to be impacted. You want it to be in a kind of, it's fictive, once again, it's not real person, but they have to be realistic. They have to be kind of grounded into this specific region, for instance, where, for instance, a person riding a car, for instance, is not going to be 100 years old, for instance. You want to avoid this kind of torture situation. So you want to control for the distribution. I think that's the first aspect. We're using it a lot with the original motivation. And the second one is really general purpose synthetic pipelines, because once again, if you're going to create environments beyond just coding, but let's say environments like, for instance, situation for healthcare assistants we are doing right now, for instance. And basically, you want to get people which have an issue with their own health, for instance, back pains or whatever. They want to ask questions. But again, the reliability of having this kind of symptoms is conditioned on demographics. This condition of, okay, what is going to be your age? And then afterwards, the application is going to ask for information, stuff like this. So you want to ground all of these things. So I think it's really about this kind of jump where we're not just going to train on text, but on the preconditions that made text happen in some ways, which I think is really, really interesting. Like almost a recipe of how a text came to be. We are almost to unlearn it. Like, especially if you're dealing mostly with forms, it's relatively easy to see. But I think even for more elaborated text, actually, which talk about, like, say, a case law, for instance. Okay, it's some person that were arguing another person, but again, they are part of society, they are part of a specific region, and so on. So you can ground all of this, and then you can create endless variations around that. But I think personas are not the ultimate thing, because what you want really is to ground that with all kind of information, which can be, again, simulated or non-simulated. You can have all kinds of things about the places, the kind of thing like that. So I think it's the reason actually that's been taking up so much recently, because I think it's really the part where we're going to move on from the synthetic pipelines, which are really closely related to text, like what is stick rephrasing, okay, we're just taking existing text, toward this kind of more creative approach. We are going to create data not out of thin air, but out of realistic combination of reality.
Okay. I think we are out of time. Do you have anything else that you want to add?
No, I think it was a great conversation. And I think what I really like is that we can have it right now, because I see that working on data as research was not obvious until very recently. It's not something you could do openly, but I still think right now, between all the advancements we have in open data, we have in static data now, it's something we can definitely discuss, and we see how much it can impact the capabilities of the models.
Pierre-Carl, thank you so much for joining us. It was a pleasure to have you.
Thanks a lot.
Yeah, thank you. It was
Thanks a
really a
lot.
pleasure
Okay.
to
Thank you, everyone.
see you again.